In this part of your notes, we're going to talk about the statistics that you're going to see often in this class. When we do labs, you're going to be asked to calculate things like percent and mean and standard deviation. So I want to work through some of these examples with you. The first calculation that we're going to look at is percent. I've included formulas, but you probably know already how to calculate percent. Anytime we calculate percent, we're going to put the part over the whole, and then we're going to times by 100 to get to percent. In the old days, when we would take tests, the test would be out of like 40 points or 50 points and so on. And students would get their paper back and it would tell them how many points they earned. That's the part. So the part that they earned is 34 points. And you divide that by the whole, or the total that was available. There's 50 points total on the test. If we divide those two, we're going to get a decimal point 0.68. And then we need a times by 100, like you see here in the formula, times by 100 to get that to a percent. Basically, that just means move it 2 decimal places to the right. So we move it, and that gives us 68%. Looking at number 2, let's analyze some data and calculate a percent. It says, what percent of the population on day 4 was species A? Looking at our table here, here's day 4. We can see we have species A, and there was 48 individuals. For species B, there was 12 individuals. Well, our part is going to be that population of species A. So our part is 48 individuals. Now the whole is how many were actually there. So our whole comes from, if we added 48 plus 12, then there was 60 individuals there by day 4. That's going to be our bottom number. So our total was 60 individuals. If we divide those two, then we're going to get 0.80 times that by 100, or move your decimal 2 places to the right. So that means 80% of the population on day 4 was species A. One thing that I want to point out, whenever you're calculating percent, you're doing it correctly if your units above are matching your units below. Here we have 48 individuals, 60 individuals. Most likely you're doing it correctly if you have the same units above and below. When we go to calculate rate, that's not going to be the case, and students are getting percent and rate mixed up. So again, calculating percent, your units that are on top should equal your units that are on the bottom. Moving on to calculating mean. You maybe have heard mean referenced as the average. And you've probably calculated average before, but if you have forgotten how to do it, then I've included a formula over here for you. Also, I want you to get used to the symbol for mean. It's an X, and I want you to extend that line a little bit. So an X with a line over it is a symbol for mean, or average. Here we have some scores, or some data points. It says you got 12, 18, and 6 points in 3 games. Calculate your mean, or calculate your average. According to the formula, we're going to add up these data points. So 12 plus 18 plus 6. And then it says divide by the number of data points. In this situation, our number of data points is 1, 2, 3. So we're going to divide by 3. When we add those up, we're going to get 36 divided by 3, and that would give us an average. You're scoring about 12 points per game. Now let's relate that to data that we would maybe collect if we were doing an experiment related to biology. So here we are monitoring the number of animals in a river area. It says calculate the mean number of eagles that were in the area through the 5 years. Looking at this table, we can see year 1, they observed 3. And then year 2, there was 8, and so on. We want the average number that was there throughout those 5 years. We're going to add up these numbers. We have 3. I'm looking at this part of the table. We have 8, 10, 8, and 6. And now we have to divide by our number of data points. There is 1, 2, 3, 4, 5. We have 5 data points. So divided by 5. When you plug that in, you're going to end up with 35 divided by 5. And that's going to give us an average of 7. So on average, there was about 7 eagles inhabiting that area of the river. Going down to range. Range is a pretty simple calculation. You just have to find the highest number and subtract the lowest number, and that's going to give you your range. Oftentimes you're asked to calculate range on your EOC exam. So it says calculate the range for the brown bear population. A mistake that students will make is they'll just they'll just read the wrong part of the graph, and they'll read for fish or for eagles, but it's for brown bears during 5 years. So we just have to find the highest number for brown bears, and that's going to be 26. So this is the highest. And the lowest looks to be 18. Subtract the two. 26 minus 18. So our range is 8. Moving on to probably a new calculation for you is standard deviation. And the reason why we're going to teach you standard deviation here is because if you take AP Bio, you're going to calculate what's called standard error. But first you have to know how to calculate standard deviation to solve for that number so you can use that number to calculate standard error. We're going to go ahead and teach you standard deviation now, so it's one less thing that you have to learn whenever you're in AP. Here's the equation for standard deviation, and we're going to go through what all these different symbols mean. Whenever you see this X with an I on it, that means a data point. Data points are these numbers that you're collecting, that you're putting in the table. The X with the line over it, we already talked about, that means mean. And this N that you see right here, this means number of data points. I tell students or encourage them to work standard deviation in columns. And if you remember how to set the columns, you can refer to the formula, and this is a pretty simple calculation. It's just going to be a long calculation. So let's go ahead and set up these columns. One of the first things that we're going to do is we're going to take a data point and we're going to subtract the average from it. Let's just list our data points. So I'm going to put an X with an I, and it says calculate the standard deviation for the eagle population. So these are the data points that I'm going to calculate the standard deviation for. So my data points that I collected, I got a 3, 8, 10, 8, and 6. The equation tells me I have a data point, I'm going to subtract the mean or the average. So let's indicate what the average is, and let's put mean here, or average, so you know what we're talking about. We already calculated the average. We added up 3, 8, 10, 8, and 6, and we divided then by 5, and that gave us an average of 7. We did that on the previous page. So let's indicate the mean for all those data points is 7. The equation says we're going to subtract these two. We're going to find the difference between the two. So I'm going to put this, and you can see that this matches this part of the equation. I'm going to subtract the average from the data point. Now when I do this, I'm going to get a -4 here. If I take 3 minus 7, I'm going to get a -4. And we're going to end up squaring this number, so you don't really have to put the negative, because anytime you square a negative, the negative is going to disappear. So my difference between these two numbers is 4. The difference between these two numbers is 1. Subtract 7 from 10 is 3. And we have 1, and we have 1. Now, according to the equation, we now have to square that number. So I'm going to write this again, because we're going to take this value that we just calculated, and we're going to square it. So 4 squared, 16. 1 squared, 1. 3 squared, 9. 1, and 1. Now we got to talk about what this funny looking E is. This means sum. So after I take the difference between the data points and the mean, and I square them, I'm going to sum those numbers up. So I'm going to put a sum here, and I like to put a line here and put a plus here to help remember what to do. I'm simply going to add those up, and that's going to give me a sum of 28. Now watch what I'm going to do with that number. I'm not done yet. I haven't calculated the standard deviation yet. Going back to my equation here. So standard deviation equals, we have that square root. This number that you calculate here becomes the top number in this equation. It becomes this part right here, okay, the top number. So I'm going to put 28 divided by n minus 1. Now let's go back to what this n is. Remember, n means the number of data points. For the eagles, I collected 1, 2, 3, 4, 5 data points. So this means n equals 5. So this number right here is going to be a 5. I'm just going to put a 5 down here in parentheses so you understand where that number is coming from. So let's go ahead and simplify a little bit. I have my standard deviation right now equals 28 divided by 4. And I want to make sure you understand that 28 divided by 4 is all under the square root. It's just not the square root of 28. So first we're going to have to take 28 divided by 4, and then we're going to square root that number. 28 divided by 4 gives us 7, and that's under the square root. When I plug that into my calculator, my standard deviation is 2.65. Now what this means, what does standard deviation mean? It means that for these data points, on average, they're about 2.6 off of the mean. That's what standard deviation means. Our data points are deviating about 2.6 from the average, or from the mean. Now, this should be all the information that you need to know in order to finish that tables, graphs, and charts worksheet.